It has already been firmly established that fingerprints are the most infallible means of identification. The whole science is based on the premise that no two persons and no two fingers of the same person have identical design on their fingertips. Therefore, it assists us in establishing the identity of the person who commits crime. At the scene of crime, broadly speaking, three types of fingerprints may be retrieved: the inked prints, which are completely visible, the plastic prints, which are partially visible, and the latent prints, which are hidden. For a very large number of cases, we get the latent prints. We also call them chance prints. Very often they are weak, they are fragmented, and that's why we term them chance prints, that by chance we have retrieved them. One or the other chemical method has to be used to detect these prints, to render them visibility. Multimetal deposition is one such technique. It tags the amino acids, proteins, and the lipid content of the sweat residue in order to make the fingerprints visible. It is so named because there are two steps involved in it, and in both the steps, the metals are to be used. In the first step, gold particles are treated on the fingerprint residue. They get attached to the fingerprint residue by electrostatic attraction. They are imparted a charge, electrostatic charge, with the aid of citrate buffer, and that charge is opposite to the charge of the zwitterion which the amino acids have. And therefore, because of this electrostatic attraction, the small gold particles, they adhere to the sweat residue. However, the contrast is not sufficient. Therefore, a second treatment in the second step is given by silver particles. The silver particles adhere to the gold particles. Now, this is a three-layer phenomena. The amino acid and protein content of sweat constitutes the first layer. The gold particles constitute the second layer, and the silver particles, they constitute the third layer. That's why it is called multimetal deposition. And as I have said, it's a two-step process. Many of the fingerprint detection methods are surface specific. That means you can use them for detection of latent fingerprints on crime scene evidence of a particular type. Multimetal deposition is a broad spectrum technique. It gives us fingerprints on non-absorbent surfaces like metal and plastic, on absorbent surfaces like paper and wood, as well as on semi-absorbent surfaces or semi-porous surfaces, as they are also called, like waxed paper and polythene. However, the technique is cumbersome. Moreover, the apparatus has to be absolutely clean. It is also a time-consuming technique. Therefore, in most of the caseworks, this has not been used. However, its academic interest is great because a large number of concepts of chemistry and forensic science are involved when multimetal deposition technique is used for the detection of latent fingerprints on different crime scene evidence.
Dear students, after studying this module, you'll be able to know that multi-metal deposition method detects latent fingerprint on a wide range of crime scene evidence. The technique is based on successive deposition of gold and silver particles on the finger ridges. The operational procedure of multi-metal deposition technique is cumbersome and complicated, and it is modified version. The operational procedure is easier. You see, multi-metal deposition is a versatile technique of detecting latent fingerprints on porous items. For example, fabric tape, masking tape, cardboard; on semi-porous items, for example, expanded polystyrene latex gloves, waxed paper, as well as on non-porous items, for example, metals and plastics. It is so named because it is a two-step process, the first involving deposition of gold and the second deposition of silver on the ridges, thereby visualizing the latent impressions. Although a technique with a very wide range of applications, multi-metal deposition is not very popular since the process of detecting fingerprints is quite cumbersome. In its modified version called Multimetal Deposition 2, some of the demerits of the original methods are overcome, yet the results obtained are no better than those of other techniques. Now, let us see the mechanism. It has been known since long that colloidal gold particles adhere to amino acids, proteins, and peptides. The multi-metal deposition technique of fingerprint development relies on the affinity of gold particles for these biomolecules, as the latter are present in fairly large concentration in sweat residue. This methodology, which is described in the next section, is a two-phase process. In the first phase, colloidal gold particles adhere to the amino acid, protein, and peptide content of the fingerprint deposition, while in the second phase, silver particles gets adsorbed on gold layer, improving the contrast. The driving force for the first phase is the electrostatic attraction between the gold solution and the biomolecules. The colloidal gold particles are produced by the reduction of hydrogen tetrachloroaurate, commonly referred to as tetrachloroauric acid by citric acid. The reaction is shown here in the figure, and beside gold particulates, 3-ketoglutaric acid is one of the products. The structures of citric acid and 3-ketoglutaric acid are also shown in given figures respectively. The working solution of multi-metal deposition method also contains sodium citrate, the structure of which is depicted here. The citrate ions furnished by sodium citrate engulf the colloidal gold particles and impart a negative charge to these, as shown in this figure. Now, the amino acids or their fragments in proteins and peptides under neutral conditions exist as zwitterions. However, under acidic conditions, the amino acids acquire an overall positive charge as shown in the figure. Citric acid brings the pH of the working solution in 2.5 to 2.8 range, thereby including a positive charge on amino acids present in sweat residue. Thus, the colloidal gold particles bear a negative charge, and the amino acids bear a positive charge. The electrostatic attraction between the two chemical entities is responsible for the adherence of gold particles on amino acid, protein, and peptide content of the sweat residue. It is pertinent to state that citric acid performs two functions. Firstly, it reduces hydrogen tetrachloroaurate ion to colloidal gold, and secondly, brings the pH of the working solution in the desired range. The gold particles adsorbed on amino acid, protein, and peptide content of fingerprint residue do not impart a pronounced color to the ridges. Nevertheless, these provide a site for the nucleation of silver particles. The latter are produced by the reduction of silver ions by iron ions. The reduction reaction is also shown here. Being a reversible reaction, there are chances that it may proceed from right to left. However, the citrate ion complex with iron ions and remove these from the equilibrium system, pushing the reaction to the right. The silver particles then settle on the colloidal gold, imparting a dark gray or black color ridges. A systematic diagram showing the adsorption of gold on ridges followed by adsorption of silver on gold is shown here in the figure. Now let us discuss the methodology. So let me tell you something about preparation of reagents first. The process of developing latent fingerprints by multi-metal deposition technique begins with the preparation of the following solution. Now, solution A has 1 gram hydrogen tetrachlorate in 10 ml distilled water. Solution B has 1 gram sodium citrate in 100 ml distilled water. Solution C has 1 ml polyethylene glycol in 100 ml of distilled water, then solution D has 4.8 gram of citric acid in 50 ml of distilled water. Now, working solution 1 or the colloidal gold solution is prepared by placing 1 ml of solution A in about 950 ml of distilled water. Then mix thoroughly and heat to gentle boiling. To it, add 15 ml of solution B and continue to boil till the contents acquire a port wine color. Now turn off the heat source and while the mixture is still hot, add 5 ml of a liquid detergent. Agitate to mix the contents thoroughly. Now cool and add 10 ml of solution C. Adjust the pH to 2.5 to 2.8 by adding 1 to 1.5 ml of solution D. Make up the volume 2000 ml. Store the working solution 1 in an absolutely clean vial in the refrigerator. Next, the following solution is prepared. Solution E, which is 20 gram of silver nitrate in 100 ml distilled water. Solution F, which is 16 gram of ferric nitrate, 44 gram of ferrous ammonium sulfate, 11 gram of citric acid, and 0.2 ml liquid detergent in 1000 ml distilled water. Working solution 2 or the modified physical developer solution is prepared by adding 10 ml of solution E to 990 ml of solution F. Agitate to mix thoroughly. The shelf life of this solution is just 15 to 20 minutes and therefore it should be formulated immediately before processing the items for developing fingerprints. Now, process for development of fingerprint. Latent fingerprints are developed by the following procedure. Firstly, the item bearing latent prints is placed in a tray and covered with distilled water. The tray is rocked gently by using a shaker of the type shown in figure. Then the item is transferred to another tray to which working solution 1 is added. The tray is shaken for 30 to 45 minutes. If more than one item is placed in the tray, these are not allowed to overlap. The item is taken out of the working solution 1 and rinsed with several batches of distilled water. Faint fingerprints begin to appear. The item is then placed into another tray and working solution 2 is poured over it. The solution is agitated for 5 to 15 minutes. The item is then washed with water several times till the washings are no longer yellow and turbid. Then the developed fingerprints, which are dark gray or black, are photographed. The item is allowed to dry under natural conditions and therefore the prints are lifted with the aid of a fingerprint tape. Now let us discuss about modified multi-metal deposition technique. The modified multi-metal deposition technique, referred to as multi-metal deposition 2, is an endeavor to make the operational procedure of the original method easier. The gold solution produced by following the modified method is more homogeneous, with a particle size of 14 nanometer. The smaller particle gives superior development as compared to the 30 nanometer sized gold particulates in the original method. The novel method not only gives more detailed rich characteristics but also visualizes pores and edges more clearly. As in the original method, pH is critical to the quality of developed prints, the optimum range being 2.5 to 2.8. Deactivation of glassware. When fingerprints are to be developed by multi-metal deposition 2 technique, the glass apparatus has to be rendered scrupulously clean. The process of cleaning glassware, called siliconization, is carried out in the following steps. Firstly, the entire glassware is soaked overnight in 10% solution of 2-ethyl hexyl sulfate. Then the apparatus is then rinsed successively with hot and cold water. It is then dried in an oven at 100 degrees Celsius and allowed to cool at room temperature. Thereafter, the apparatus is soaked in a treatment solution of 5 seconds. The treatment solution is prepared by dissolving 4 ml 3-amino propyl triethioxylane in 200 ml acetone. The structure of 3-amino propyl triethioxylane is depicted in the given figure. All items of glassware are rinsed twice in distilled water. and finally dried in an oven at 42 degrees Celsius for 24 hours. Now, let us discuss preparation of reagents. The following solutions are prepared. Solution A: 1 gram hydrogen tetrachloroaurate in 10 ml distilled water. Solution B: 1 gram sodium citrate in 100 ml distilled water. Solution C: 0.1 gram tannic acid in 10 ml distilled water. Solution D: 1.05 gram citric acid in 50 ml distilled water. Now, working solution 1 or the colloidal gold solution is prepared as follows. A 0.5 ml aliquot of solution A is diluted to 400 ml with distilled water, and the contents are heated to 60 degrees Celsius. In a separate vial, 20 ml of solution B and 0.1 ml of solution C are diluted to 75 ml with distilled water, and the contents are heated to 60 degrees Celsius. The contents of the two vials are mixed while hot, and the mixture is heated to boiling. It is then allowed to cool at room temperature, transferred to a polythene bottle, and stored in a refrigerator. Immediately before use, the mixture is restored to room temperature and 0.5 ml of a commercial liquid detergent is added. The pH of the working solution 1 is adjusted in the 2.5 to 2.8 range by adding 1 to 2 ml of solution D. Now, working solution 2 or the buffer or hydroquinone solution is prepared by adding successively 50 gram citric acid, 47 gram sodium citrate, and 1 gram hydroquinone to 200 ml distilled water and stirring till complete dissolution. The structure of hydroquinone is shown in the given figure. Then working solution 3 or the modified physical developer solution is prepared by dissolving 0.2 gram silver acetate in 100 ml distilled water. Silver acetate stains the background of to a lesser extent as compared to silver nitrate solution, which is used in the original method. Working solution 2 is stored in a dark container. This solution is prepared immediately before processing of fingerprint development. Now, let us discuss the process of development of fingerprints. Latent fingerprints are developed by following procedure. Number 1, if the item in question is non-porous in nature, it is given a quick wash with distilled water. The semi-porous and porous items are soaked for about 2 minutes in distilled water. Then, the item is placed in working solution 1 for 20 minutes. It is gently agitated. Then the item is rinsed with distilled water. To it, a 100 ml aliquot of working solution 2 is diluted 200 ml with distilled water, and the item bearing latent fingerprints is soaked in this solution for 2 to 5 minutes. Then the item is transferred to a tray containing a mixture of 100 ml working solution 3 and 100 ml working solution 2. It is soaked for about 20 minutes and gently agitated by mounting the tray on a shaker. Finally, the item is rinsed 2 to 3 times in fresh batches of distilled water. The developed fingerprints are photographed, allowed to dry, and finally lifted. Now, my dear students, let us summarize this chapter. So, in this chapter, we have learned that the multi-metal deposition method of fingerprint detection, as well as its modified version, involves successive adsorption of gold and silver particulates on the amino acid, protein, and peptide content of sweat residue, visualizing the ridges as dark gray or black impression. The technique is not surface specific, that is, it works on a host of non porous, semi porous, and porous surfaces. Despite its broad spectrum application, the method suffers from several demerits. We have also come to know that too many reagents are required for detection process, and the steps involved are complicated. Then we have learned that the glassware ought to be meticulously clean. The process entails a high cost, and lastly, we have learned that due to these limitations, the process is of academic interest only.